Hi class, today's lesson is lesson 4-2. It's on factors and prime factorization. Please write down the purpose for today. Purpose is to write prime factorizations of composite numbers. Before we look at the examples, we're going to go ahead and take a look at the vocabulary terms that we need to jot down. So go ahead and turn to the back of your composition books in order to write the terms and their definitions. The first term is factors. Factors are whole numbers multiplied together, resulting in a product. In this example here, we have 2 times 5 equals 30. This is a multiplication equation, and the factors of this equation are the 2 and the 15. These are factors, 2 and 15, of 30. Prime factorization. Prime factorization is writing a number as a product of its prime factors. Here we have an equation, 24 equals 2 times 2 times 2 times 3. Each one of those numbers in that product, as written as factors, are prime factors, are prime numbers. 2 times 2 is 4, times 2 is 8, times 3 is 24. Now we can do prime factorization for any positive whole number. Let's go ahead and take a look at some of the examples here. First it says, list all the factors of each number. It doesn't say prime factors or composite. It just says all the factors. So we're going to list the factors in this way. Some of you may have known this as the rainbow method. So I'm going to put a colon there, and I'm going to put the beginning of a parenthesis here. First I'll start with the number 1, because 1 is a factor of all whole numbers. 1 times what is 18? Well, I'm going to go ahead and skip down here, and I'm going to put the 18, because 1 times 18 is 18. Next, I'm going to put a 2. 18 is an even number, so I know it's divisible by 2. And since I know my math facts, I know that 2 times 9 is 18. Now, I take another number. Now let's try 3, and I know that 3 will work here. It's 3 times 6. Notice what I'm doing is I'm writing my factors from least to greatest. I have 1 and 18, 2 and 9, 3 and 6. Notice that it looks kind of like a rainbow. Now, using this method, I'm left with the numbers 4 and 5 that are between the 3 and the 6, and 4 does not work as a factor of 18, nor does 5. So these are all the factors of 18. Next, I'm going to do the same method with the 13. I know that 1 is going to be a factor of all whole numbers, so I'm going to put 1 in 13. Now I'm going to go through and think about 2. 2 doesn't go in it. 3 doesn't go into it. 4 doesn't go into it. Well, there's no other numbers that go into it because this is actually a prime number. Therefore, we just have 1 and 13 in our rainbow. These are the factors of 13. Now let's take a look at a little bit of prime factorization. This is actually a fun part. It says write the prime factorization of each number. So we're going to look at all the prime factors that when multiplied together give us 36. The factor tree is this. I'm going to start with 36 at the very top of the tree, and then I'm going to draw 2 branches. Now I can pick any 2 factors. It doesn't have to be prime factors at this point, but by the end I'll have just prime factors. So we have 36. I can pick 4 times 9, 6 times 6. Let's go with 4 times 9. 4 times 9 we know is 36. Now I'm going to, as I go along picking other factors and adding other branches, I'm going to try to get to prime numbers. Do I have prime numbers that when multiplied together combine to get 4? Yep, absolutely. 2 times 2. Are they both prime numbers? Absolutely. I'm going to go ahead and circle them. Don't need to have any other trees off of those, or any other branches off of those numbers. For number 9, we do have a 3 and a 3. 3 times 3 is 9, and they're both prime numbers. So what we have here is, in the end, a 2 times a 2 times a 3 times a 3. 2 times 2 is 4, times 3 is 12, times 3 is 36. That's the prime factorization. 2 times 2 times 3 times 3. Now we can do that also with other combinations. Let's do that 6 times 6. Well, what goes into 6? Well, it's 2 times 3. Are those prime numbers? Absolutely. And over here, same thing, 2 times 3. Prime numbers? Absolutely. Notice we came up with the same prime numbers. Regardless of where we start, in the end, we'll have just one set of unique prime factors. When multiplied together, will give us the top of the tree. Notice also that these are going to be put in order. 2 times 2 times 3 times 3. We want them in order. Okay. Next, we'll do another method. This method is called the ladder diagram. Here we're going to take the 54 and we're going to look for the prime factorization of 54. First thing I'm going to do is I'm going to divide it by a prime factor that I know is in there. Well, I'm going to do it with a 2 because I know 2 goes into that. Well, you know, I drew this upside down, so let me start that over again. 2 and the 54. 2 goes into 54, let's see, 27 times, so I'm left with a 27 over here. Now I'm going to draw another part of the ladder here. See that? What prime number goes into 27? I know a 3 goes into 27, leaving me with a 9. And now I know a 3 goes into 9, leaving me with a 3. So if I did my calculations correctly, 2 times 3 times 3 times 3 equals 54. I'm going to write that out. 2 times 3 times 3 times 3 equals 54. We have 2 times 3 is 6. 6 times 3 is 18. 18 times 3, 54. 18 times 3, 54. All right. Now, with that said, we've got problems for you. 4 problems to be exact. You're going to list all the factors of these numbers, prime and composite combined, using that rainbow method that we talked about, the rainbow method. And then here you're going to write the prime factorization of each number. You can use the factor tree. I want you to use the factor tree with this one. And then I want you to use the ladder method with that one. All right, we'll see you in class.